Alright, it seems to have started over. Who knows? Yeah, I don't know. I don't know exactly what wrong there. I don't know. YouTube's fault, my fault. Guess it doesn't really matter. It seems a little laggy still, but we'll hope it doesn't crash again. It doesn't appear like it's going to. Alright. So I guess it's a video. Let's see what happens. So where was I? Oh, okay. I have to do. Firefox is now gone for whatever reason. I have to find that. Oh, shit. Yeah, everything's broken. Alright. Let's see. That looks right. Okay. It hasn't showed up there yet. Alright, doesn't really matter. Alright. So this will be about energy, I guess. And silly definitions. So obviously I would argue that energy is kind of obvious. It's just a combination of mass and motion, and that equals something's ability to influence something else in the universe. Just how many pushers, how many people, and how fast are they going. I mean, that's all there is how much pressure can you apply. And having fewer people going faster is not more energy than a lot of people going slower, because it all comes down to just a pressure or a weight that you can apply, and all of that just has to do with how many electrons and protons are going to be banging into each other. That's really all there is. Alright, so the stupid Dispar creep did make a video, apparently. No, I don't need to do that. I just go over here somewhere. Yeah, there. Oh, these people are just so intrinsically creepy. So he's made a video so that, they don't touch any of the theory, they don't touch any of the arguments, they don't explain anything, and so he makes a 56-second video where he's going to somehow explain the simple difference between velocity and acceleration. Like somehow they're in some way fundamentally different, when one is just velocity and one is, hey, your velocity changed. So what? Change back again. It's not like a big deal. So it changes and it goes back, or it doesn't, or it keeps changing, or who cares? It's just something going a certain speed. I mean, all a change in your velocity is yeah, in 1 minute you can have 1,000 people going 5 miles an hour, then you have 1,000 people going 2.5 miles an hour. It's still just how many people going how fast, and that's all there is, and that's all you can add or subtract. And that's clearly what Newton was saying by saying you want to go twice as fast, just to apply twice the force, clearly implying that force is essentially, if you keep the mass, if the mass isn't going to change, then the force is velocity. That's it. But anyway, so he's used a clip of me somehow in this 8-second video. I mean, this is just such puke. The acceleration due to gravity is not. Alright, so for whatever reason, he's done this crap. So there won't be any theory here. There won't be anything valuable here. This is just going to be a piece of steaming shit. 0.8 meters per second. Okay, I gotta be louder than that. Yeah, this one has to go up. This one has to go down. Yeah, okay. Well, we'll increase this a little because I can't be loud enough. Second. No, it isn't per second per second. That's silly. Okay, so you want to be a. So yeah, I mean, it is silly. There's no good reason for it. No, why would you say per second, and then write it as scientific notation as second squared? Per second doesn't even mean second squared. So even if it was stupid enough to say per second, you have to be a real crazy fuck to sit there and say, well, I'll notate that as second squared. When, how does squaring the seconds mean that I did it once and then I could do it twice, or I could do it 4 times, or I could do it 17 times? How is squaring relevant to the fact that, well, what if I only did it 3 times? What if there's only 3 seconds I was falling? How is second squared going to tell me it was 3 seconds? It's not going to. Retard, you want to prove you're a moron and an idiot? Nobody says I went 60 miles an hour per hour to the store. No, I went 60 miles an hour. That's already says it. You can't go per hour. You can't go per second. It's all baby talk. There's no fucking such thing. Every rate can always be. You did it for 6 hours. You did it for 2 hours. You did it for 10 hours. You did it for 500. So most of his video is me saying it. Is there any part of the video going to be his counter argument? Hours. It's never squared. That's just absolute nonsense. So this is basically the same chart where you measure something measured in time times time, which is idiotic on its face. I mean, there's already a unit of time here. You can't times the time times each other. It's just stupid. So this is his evidence. This nothing. 30 meters per second, green line times time. Somehow that proves it's second squared. Oh, okay. An object travels with a constant speed in time from point A to B. All right, so this is his moronic argument. Yeah, an object travels with a constant speed from time point A to point B, so it's not even accelerating. Okay. Alright, an object travels from point A to B with a constant increasing change in its velocity. Yeah. So its velocity is changing. Why is this interesting? Alright, the unit so this, you can't even make the video, right? He's this little crappy little chatty crap. Yeah, can you see this crap? Yeah, you can see the crap. Alright, the unit is meters per second. Why? It's retarded. Okay, because the velocity, okay, meters per second, is changing every second. So it's changing every second, which means how many seconds was it changing is what you have to multiply it by. You multiply it by how many seconds it changed. You don't multiply it by itself. I mean, I'm going 30 miles an hour for 1 second. Why would I square 30 miles an hour? That's not going to tell me I went 30 miles an hour for 1 second, or 10 seconds, or 20 seconds. It's too stupid. Alright, it is the amount of velocity per second. But you're squaring it. It isn't the amount of velocity per second. If you square it, then it's 9. You know, 30 miles an hour is 90 miles an hour. So what are you talking about? That doesn't make any sense. All right. And since the unit velocity is ms, we write we. Who's this we? You don't know any physics. Oh, that's just so, you know, we write meters per second per second. Again, so this explains why everybody else should be an idiot. What a brilliant explanation. Everybody else should be really stupid. They should think that, let's say you're trying to convert velocity into some other, you know, you're a pen collector and you collect pens at, 3 per second. well, why would I multiply? Why would I multiply 3 times 3? Don't I have to count how many seconds I collect pens, and then multiply times that number? I mean, isn't the units of time separate times? They're not the same time. The amount of the amount of time measuring how fast I'm going is not the same time as the amount of time I went that fast. It's not even the same t, you stupid idiot. Oh, fuck. I mean, how many times you do something, okay, doesn't mean you square the something. I mean, I shouldn't even have to explain that. So that was it. So this is their great counter argument. What a piece of shit. After all these crappy videos, I mean, to do this. Oh, that's so compelling. Alright. So the comments will have to do. Yeah. Waste time on the moronic comments. All right, hi Dispar. I was thinking of a little experiment that can show the relation between potential. So here we are again, right? So this has been over so many times, this whole lie about potential energy, and trying to use kinetic as opposed to active energy versus stored energy, and as if, or wells of energy. And that somehow that distinction is some justification for using the word kinetic when it's not. Okay, kinetic is specifically now tied to the silly 1/2 mv squared equation, which is crap. I mean, they could say momentum here, momentum energy, just as easy. Maybe it is something for when you have some more time. If you have a thin rectangular piece of wood that hangs down from two wires from a single point so that it can swing like a pendulum, you can measure the velocity with your upside down photo gate when dropped from a horizontal position. Who's disputing these facts? Again, what, is somebody disagreeing that stuff, you drop it 4 times the height, you double the velocity? You only double the velocity, you don't quadruple it. Is somebody disputing that 4 times the height gets you twice the weight? Is somebody disputing that it's twice the amount of time to fall, 4 times the distance? The point is why are you ignoring all the twos and concentrating on one aspect that, you can figure out if you're a little bit smart. You can figure out how, well, that's kind of deceptive because the faster you move through the gravity per second, the per second gravity, okay, the gravity is being imposed per unit of time. And the faster you move through it, the less units of time you'll be in the gravity. So I've made the argument so many times, and they just ignore it. They think how much paint will hit you from a paint spray, spray paint. I move a spray can across a surface applying paint, and they think it's the same amount of paint no matter how fast I go. Same paint. Yeah, that's what they think. That's what they're defending. They're so goddamn stupid. Okay, the two equations, E equals mgh and E equals 1/2 mv squared, give for the velocity. Well, that's a great sentence. V equals, alright, I don't know what that is, square root of 2gh. So they're just playing a game. Because they squared it, they have to square root it. Oh, well, that's a really interesting. Where h is measured from the pivot point of the center of the mass of the probe, of course, and h equals 0.4 meters per second. What do you think? I think that's an absolute lie. Okay, we already know what the velocity is going to be. So you're just lying to say when I drop something from 4 times the height, it goes 1.4 the velocity. No, it doesn't. It goes twice the velocity. So lie some more, retard. Hey, yes, that's a great idea. Amazing. Anyway, just fucking amazing. Now that I have these expensive photo gates, it's a great advantage, and I should do much more experiments with them. That just occurred to you? You bought them, and it just occurs to you that maybe I should use them. Oh. Now, well, the problem is you're really dumb. So every experiment you'll do will be a piece of shit. Because you really don't care about finding the truth. You're just trying to do propaganda videos for bullshit. Alright, for the moment, it's just laying untouched in a box. So this makes no sense at all. But next month I'll have more time. He's always talking about this time when he'll have more time. And he can do more crappy experiments. Alright. I will do more lever tests. Maybe I could use photo gates to measure the velocities of the swinging levers. So, proving what? I mean, you can't change the fact that obviously if you put a 2 mass on one side, one distance, you put a 1 mass, 2 distances on the other side, you can't change the velocity numbers. Because the lever's a rigid bar, you can't change it. So what are you going to prove with that experiment? Alright, anyway. Also, I'd like to try out some kinetic energy collision tests, some kind of experiment where they measure the impact of the crackers. So he's going back to the stupid moronic cracker video. that was obviously flawed because they didn't even use the velocity when it was hitting the wall. They used the velocity after it had traveled, a yard, which means that obviously, just from, you can know from the physics, if you know any physics, you can understand that the velocities aren't going to be anywhere near the expectation, because the slow object gets hurt by friction a lot more than the fast object, because it's gravitational friction. So I made all of these arguments previously. He just ignores every one of them and then just keeps saying things that are just really, really stupid. And you're just like, what the fuck? Banging things into crackers? I'm going to test the energy by banging things into crackers? The video that I linked to in a previous video of mine, yeah, that stunk for hundreds of reasons, literally, okay? I mean, it was so poorly done. It was such an unscientific pile of shit. All right, but I want to try out different objects to measure the impact, and also next month I'll contact the physics professor that I was redirected to. So none of that ever happened, right? All this stuff that was supposed to happen that never happens. I like the video with the box of crackers. It wasn't a box of crackers, it was one cracker. I must say, a great experiment. It's good there's only 5 of these people. I mean, this is so stupid. To defend a stupid video, no quick releases. They measure the velocity as an average over a long distance, comparing something going twice as fast, which means obviously the thing going slow is really going to be hurt over time. The longer you wait to let them hit the cracker, the more likely it is the heavy object is going to be losing a lot more energy a lot quicker than the lighter object, who's been evading losing its energy by going faster. Okay, Goofy can no longer say there are no experiments that show kinetic energy. So, I mean, this is so bad. The video shows once and for all that the kinetic energy is larger where the momentum stays the same. So they didn't hit the wall with the same momentum. That's an absolute fact. Absolute fact. Undeniable fact. Okay? And if you did measure the speeds, you'd see that they didn't hit the wall with the same momentum. They didn't hit the cracker with the same momentum. It's an easy discernible fact. Okay, that over the long distance they traveled, it's clear that the heavier object has lost more of its momentum. Just a fact. It's just terrible. So this is what they're defending. A stupid experiment with no, like I said, that has just no, it's so incredibly stupid. And he's saying, oh, there's your proof. I mean, that's how cheaty these people are. So this is what human beings will do to the truth. I mean, right in front of us, just raping it, Beautiful, simple, and to the point. So how is it to the point? Per second somehow makes sense when you're multiplying the wrong thing times the wrong thing. So you're supposed to be multiplying the rate, 30 miles an hour, times the number of hours, and instead you're multiplying 30 miles an hour times 30 miles an hour. And you say that's simple and to the point of what? If your point is you're an imbecile and stupid and moronic, well, then it's to the point. Okay. John Walker, thanks Dispar. Nothing difficult. 5 seconds times 9.8 meters per second equals 49. Yeah, no one's disputing that part. That's doing it right. Oh, no, he has the squared here. The 9.8 meters per second is squared. So not only is he's counting the seconds and now multiplying the seconds, the number of seconds you moved at that speed, times 9.8 meters, and squaring it. Yeah, so he's doing both. So it would have been just by squaring it, you're just multiplying the wrong thing times the wrong thing. And then he multiplies the right thing also, guaranteeing a preposterously stupid answer. So that's just too stupid. Goofy obviously doesn't know how to handle units properly. No, I do understand that if I'm going 60 miles an hour and I do it for 5 hours, I multiply 60 miles an hour times 5. I don't multiply 60 miles an hour times 60 miles an hour. I'm not that stupid. Okay. Stay safe, dude, whatever that means. God, I just hate human beings. Oh, look, a Brozo comment. How very stupid this will be. Alright. And he thinks he's deserving a Nobel Prize. I'm thinking almost anybody who can show any kind of reasoning skills deserves one, apparently. Because humans are really, really stupid. Again, this isn't complicated. Per second. You say I should multiply 9.8 times 9.8 to find out how many seconds something fell at 9.8 meters per second. That's really dumb. Alright, can't even grasp the concept of acceleration. I can't understand it as a magic unicorn. Acceleration isn't a special case in any way. It's just saying you increased its speed by 30 miles per hour, let's say. You just say it the same way you define a velocity. And all you're saying is I added or subtracted 30 miles per hour from the rate it was going. Period. So if we're going 0 and I add acceleration, all I've added is a velocity. So why would I square the velocity? Shocking. You should be embarrassed. We'll see who's going to have embarrassed written on their tombstone. It's not going to be me. Clue. Okay, but remember, he's the guy who claims he's back to the loudspeaker. I'm not even going to read that crap. He thinks this is because another piece of ridiculous juvenile guesswork. Okay, just a waste of time. I've actually recorded speaker. Oh, he's going to just talk about speaker cones. I mean, just amazing. Another reason he has a shockingly wrong about. She's just going on and on. Oh, amazing. Okay. If he's right that there really was, the argument was really about the speed of sound, okay, and the fact that to make sound, you have to, just like to make waves in a rope or something else, you have to actually move the rope faster than the speed of the propagation of the wave. So if you want to make something happen, you have to put in more energy than the tension that's built into the medium that you're pushing it through. So whatever the speed of sound is whatever the speed of sound is in a medium, that's the speed you have to go that fast to create something that will make noise. So this doesn't make noise because it's not fast enough. I don't get to move enough little pieces of air and other crap to make a sound. But if I do it so I do create tension and enough speed, it will make a sound. So all sound is sonic booms. That's the theory, and you won't argue that. You just keep arguing about speaker cones. Alright, anyway. So this has absolutely nothing to do with the subject. So again, it's just, what the fuck? Could you make a relevant comment? You could try really hard. The guy really is just utterly clueless even about the simplest technical matters, right? And this is a guy, Brozo can't figure out that if he measures the voltage, he's not measuring the wattage. So he's a Sparky, and he doesn't know the difference between a watt and a volt. Okay. His response when I corrected him years ago, so this was years ago, and I was just making a general statement about general functions. And all of this crap is just in his head. His own little magical, I somehow proved your theory wrong by saying you made an error in a technical schematic of your speaker function. The error is irrelevant to the point. But it just goes on and on and on. That there is any different kinds of speakers. That there are many different kinds of speakers. Well, there are. He just happened to be describing one which nobody in their right mind would employ for anything. So that's not accurate either, because they're employed all the time now in all these smartphones, and the rest of this stuff is using a very different speaker than the ones of traditional function. But the point is that he only came up with this nonsense story about how loudspeakers don't work. So he's just obsessed. Just to support his unsubstantiated claim. Yes, it's just a claim I'm making. I'm telling you that, yes, this is true. The reason why the bullwhip makes a sound is because the tip of the whip actually does go faster than the speed of sound. And that's what's necessary, is mass going faster than the speed of sound. The more mass going faster than the speed of sound, the more sound. Okay, can be produced by movement faster than the speed of sound. Well, if that's the case, capital letters, considering a tuning fork. So I guess how's a tuning fork going to prove me wrong? Look at slow motion footage of a tuning fork, zoom in of the image of the tangs going back and forth, and then do a calculation of how fast they are moving depending on the note. Yeah, they move a distance. So, okay, so yeah. So depending on how aggressive you have been, they move more distance, and less aggressive, less distance. Observing a 40-40 tuning fork at maximum volume, whatever that means. How do you observe it at maximum volume? Well, anyway, showed them only moving some fraction of a mile per hour. So that doesn't even make any sense, right? We obviously know they have to be vibrating at a much quicker speed, not 800 or so. So does that make any sense to you that something's vibrating 440 times a second, right? And somehow it's not moving faster than a mile an hour? Anyway, even slower as the sound dies down, yet you can still hear it. Now, whatever. I haven't seen any such evidence. You are absolutely right, Stephen. Goofy doesn't even understand that, like the sparse pilot. I don't know what that means. A railgun can accelerate a probe to 90 miles per hour in 4 seconds. So what does that have to do with momentum versus kinetic energy? Hard to figure. Alright, so that was absolutely useless. Yeah, just useless mush. Alright, let's see if there's some comments, and I guess I'll talk a little bit about relativity, I guess. Alright, so this guy obviously wants to be blocked. Mike, let's see, one sentence. Sentences. One word sentences. That's acceleration versus velocity. To change velocity, you need acceleration. La 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 la. Little pixie dust. It's the instantaneous change. There's nothing instantaneous in the universe, so that's just showing you're a baby. You don't know that there's no real random, and that there's no real spontaneous, and there's no real instantaneous. Okay. It's calculus. No, it isn't. You don't need any calculus to figure out that, okay, I'm going 60 miles an hour, and I want to figure out how many times I do the 60 miles an hour, and I say, well, I do it 5 times. Okay, so I do 5 times 60. You're saying you do 60 times 60. That's how you do it. And then you multiply it by 5. And you're saying that's smart. And I'm saying, quite obviously, no, that's really fucking dumb. Alright, okay. If second squared is wrong, then calculus is also wrong. Well, that's just another lie. This is wrong because there's, first off, they put how you measure a velocity, and then they say that's what a velocity is. So I choose an arbitrary amount of time, and then I measure how fast something's going, and I say that's its acceleration or its change in velocity. Because I measured a certain amount of time and a certain amount of distance, and I put time and distance into the equation, and then pretend because I put time in, now I can multiply time times time. When no, the velocity is a rate. It's not a amount, it's a rate. 60 miles an hour is already a rate. Okay, it's already got miles, it's already got time and meters in it. You don't put time and meters in it twice. Okay. Miles per hour times hour equals miles. Well, that's not what you're doing. You're doing miles per hour times miles per hour. You're multiplying to 60 miles per hour times 60. Okay, you're not multiplying it times 1 hour. If you multiply it times 1 hour, I would be perfectly satisfied. Because obviously that would be a pointless waste of your time. So if you did it right, which is, yes, just multiply an hour times an hour, then you'd be all right. But that's not what you're doing, fuckhead, asshole. Let's see, to change the velocity, that requires a separate rate, which is acceleration. So what? It's still just a rate. And you do the rate for a certain amount of time. Don't you understand? It's a rate. It's already a rate. A rate means you do it in a unit of time. And you're saying, well, how many units of time are there? Well, that's what you multiply it by. You multiply the rate times the number of times you did the rate. You don't multiply the rate times itself. Oh, fuck you. Oh, calm down. Fuck you. You're arrogant shit. Yeah, pull in your whatever, your pompous douchebag, I know something attitude. You just show up here and start spouting crap. This is the only subject basically on this channel for 2 fucking years. You know nothing about the previous conversation. You're completely out of the context. And you just show up and do your little, it's per second. Who doesn't know that? People really are just such pieces of scum. Anyway, so enough of the comment crappers. The morons of the human race. Alright, so let's do something different. Oh, you can see his little comments. Huh, funny. They're supposed to be in this window. They're not in there. That's really weird. What the hell, chat, is in this box? That is really strange. Alright, there's 2 of them. Let's see which one it is. Okay, that one doesn't work. Let's see if this one works. There, that one has crap in it. Cool. Alright. So we'll get rid of this and do some drawing. Alright, so the relativity argument. I have pointed out, I really haven't... all this stuff you have to think through. This is like the twin paradox. You can really waste a lot of time, trying to figure out all the moving pieces and whatnot to cut it into the essence of the argument. But so relativity people are of the opinion there's no real absolute movement and there's no way to detect it and all this other kind of crap. And I would argue that, yeah, there is. Obviously you can't do it within the relative frame, but you can certainly do it from outside the frame. And so the simple argument would be is that any time I create a collision between uneven, masses, I can understand, relatively speaking, that I can detect their absolute, I can absolutely know which one is really moving, because what will happen will be different depending on which one is actually doing the thing that's different. Actually has the, what would you say, the greater energy, the real difference from their sameness. Which one's carrying the real difference from all the other stuff that's same? So in the same frame, we're all moving through space in the galaxy, so you just consider that some movement that they both have. And then they're not going to share a movement. And so the simple truth is let's put this mass in mass, okay. And so we're going to have a velocity. The velocity is going to be same for both experiments, right? So I could just draw the 2 experiments. All right, and so in one experiment, I'm going to say the 1 mass has the velocity. And the other experiment, we're saying the 2 mass has the velocity that's different. That is the thing that's causing them to move into each other. And I guess you could have a third circumstance, which that's where it gets complicated, because I really haven't calculated out what it would mean if half the velocity was here and half the velocity was here. So the 1/2 case is, I haven't really thought about. So if the 2 mass is moving, obviously there's more going to be more momentum in the collision. So in the first thing we can notice, and I can make this 20, I can make it 20 to 1, so it would be more obvious, that the total momentum of the crash is going to be different depending on which one of these objects is moving. If this one's moving, it's a tiny amount of momentum in the crash. If this one's moving, there's a lot of momentum in the crash. All right. Because it's always, the crash is at the same end velocity. The two things are moving towards each other at the same velocity in all these examples. And so the simple argument is, if the big thing is the thing with the energy, then they both end up leaving together, going the same way. They both go this way. If this one hits this one, they end up going in different directions, in the sense that this one will go this way, and this one, well, I should draw the outcome over here. Can you see that? Yeah, you can see that. All right, this one's going to be going this way, and the little one's going to be going this way. Because it won't be able to get its energy in because it's the wrong mass to velocity ratio, so it's going to do a little bit of reflecting. So the point is, you will still see the difference overtly, in the sense they're going the wrong direction. But you'll also see the difference because there'll be less momentum. This will be going very slowly. And this example, they'll retain more or less of their velocity based on who had the momentum. So the total momentum, although that will be conserved for what you started with and what you finish with, these two examples will not have the same MV. So even though you're saying you can't tell which one is really moving, you really can, okay, because they don't have the same MV as a system. I mean, it's kind of obvious that they can't possibly be indistinguishable in terms of the outcome, because they have the two experiments have a different amount of momentum depending on which one is really moving. It really matters which one's really moving. It's a different answer. And in this case, where they both bang into each other, they both bring momentum into the example. I don't know if we have a good experiment of that, so I'll just wait and have to think about that one, question mark. So, I mean, clearly, it's basically, this is saying to you, okay, you can believe in relativity, but the fact is there is absolute indications. We can see it in the actual physical world that it really does matter if this one has the velocity or this one has the velocity. The outcomes will be different. They won't have the same outcome. It will be detectable. Now, yeah, you can't detect it while you're sitting inside the train or whatever you want to, some dopey argument you want to make. But even in that case, you can tell the difference. I can have these things on a pendulum. Okay, I sit in the train and I can lift the one mass and I can see that it gets a result. And I can lift the two mass and see that I get a different result. Creating the same velocity. Raise them to the same height. They have the same velocity. The collision will have two different momentums. And I'm inside my frame. I'm doing it while I'm riding in the train. So clearly indicating that one of them has the absolute velocity. One of them actually is carrying more energy than the other one. And that's what you're going to detect, is which one is carrying the energy, carrying extra difference, a change that is additive. Because if the change was merely you were subtracting from some previous velocity, well, the fact is then the other object is the one with more energy, the lighter object, and then its momentum into the other thing would be the argument. But clearly that's not how it works. The fact is, gravity did give this one actual energy, or does give this one actual energy. It's not relative motion, it's an actual motion that actually gives it more momentum. One of them really did move in gravity, collecting gravitational energy. The other one didn't move into gravity, losing energy. Yeah, because the outcomes are different. Alright, just thought I'd throw that in there. I mean, it's a subject, like I said, it's kind of... But I'm just saying this could be a very simple and easy way to point out how, relativity theory, just like all the rest of these theories, hasn't really been thought out very well. And although they gave some consideration to the paradoxes created, like the twin paradox, they didn't really spend much time hard testing the theory that somehow there's an equivalence principle and that all energy is the same and that all motion is relative and that there's no such thing as absolute motion in the universe. When I would argue, clearly there wouldn't be a difference between the two experiments if there wasn't an absolute motion in the universe. Two experiments come out the same if it wasn't for that absolute difference. Okay, when masses crash towards each other, are they just pushing away each other rather than being pulled from each other? When masses crash towards each other, are they just pushing away each other rather than being pulled from each other? Wow. Sorry, don't know what the fuck you're talking about. Pulled from each other? Yeah, sorry. I just can't. It doesn't make any sense. I will say that the complication is that you can only hit a force, right? So let's just say all of its electrons and protons. And so as I stated yesterday, the only electrons you can hit on something surface, my surface, any object that's going to cause some sort of change, is obviously you have to hit stuff that's moving off away from the surface. The stuff moving in on the surface isn't going to be something you can hit. You can't hit something moving the same direction you are because you're going much slower than it's likely going. Is a first case argument. And so all the collisions are, this is something I started with 10 years ago, was just this simple argument that all the collisions are really between things going the speed of light. All the collisions are just using, matter is just a conduit. Matter just allows force to interact with force. And the forces are all moving the speed of light. So you can sort of understand that all of the interactions that really happen are just collisions between a force pushing a piece of matter and a force not pushing a piece of matter. So you could argue that all the interactions are just really using mass as a conduit for forces to interact. They can't hit each other in free space in any way that is recognizable, but they can hit each other if they're pushing matter. Then they can basically do the simple thing where they hit each other and both reflect. So that's the essence of the function, is really just one force opposing another force, and the matter allows them to do that, where without the matter they can't hit each other, or they can't hit each other in any way that isn't a pure exchange. They can't hit each other at angles, so you could argue that the force bits can only do pure exchanges, and that matter allows them to do the weird one, where one hits some part of the matter and the other one's in the center of its mass, and then you get some weird reflection that isn't either one of the original motions. The original motion was this, and what you end up with is a reflection that is this and that. That isn't either one. They're not. Neither one is going. They haven't exchanged their directions. They've instead had their directions blended with the direction that the electron was going. The collective direction of the electron. So that's probably a really important thing. It's a real subtle underlying subject, but it's one of those subjects that I would imagine that 100 years from now, if somebody's playing this video, they'd say, see, that was a really important part where you're talking about just the nature of the force itself and how you can change where if the universe itself is just allowing things to switch direction, which one's going which way, which doesn't change anything. Everything stays the same. You're just changing who's moving one way and who's moving the other way. And the matter allows you to take a collection of motion and then have the object interact with the collection of motion and therefore create two uniquely new directions in space. which is that's the nature of change. The nature of change is they didn't exchange. So you just didn't change. A was going this way and B was going that way. You didn't just say, well, now B is going this way and A is going that way. You didn't just exchange it. Instead, you created two uniquely new directions that the two pieces of force are traveling. And that's the change that matter imposes on force. But sort of a little bit deep and technical. To get into all the dynamics of force density in the universe, and how just the fact that the force, if there was no matter in the universe couldn't, it's stupid to say change, because it's certainly all the force would still have a unique destiny. What's the thing to say? It's just that obviously the introduction of matter means that the force won't do the same thing every time you ran the simulation. So if you had the same force shoot out doing the same thing, it would come out the same way every time. But if I put matter in, then I'm going to force the force to change. And so then I can have lots of different outcomes depending on where I put the piece of matter. That's not really the best way to describe it either. I have to think about it. So we'll do that in some future episode. Back to the tuning fork. I was just thinking about the tuning fork and what Brozo's not considering, right? So he's saying, look, I can go back and forth, but I'm going back and forth over a tiny distance, and so therefore my velocity is averaged to be very slow because he's averaging it. That's the problem. The point is when the tuning fork is vibrating, it's what it's really doing. It's going fastest right through the center like a pendulum. Its fastest motion is here when it's accelerating, and then it pushes out and it slows down, and then it has to speed up coming back the other way, and then it has to slow down, and then it has to speed up coming back the other way. So the average velocity of the sweep isn't what's important. It's the moment right there in the middle that matters. And so it's the velocity, the maximum velocity. That's the velocity you have to understand is the only one you need to make the sound. So all you need is one place where the acceleration is higher than the velocity of the speed of sound. So all you need is one moment where it's moving faster than the speed of sound, its acceleration. So it's not an average velocity. It's a peak velocity that you have to discern. So you have to figure out what the peak velocity of the vibration is. And I'd argue that peak has to be pretty high because you have to start and start in reverse direction. And all of that is averaging out to a much slower velocity than your peak velocity. See, all that stuff, you have to, all of these subjects need to be thought out and teased out, and nobody's doing it. And I'm trying to get people to do it, and they won't do it. I'm soliciting them. Make videos on the subject explaining your theory. If you have some theory about how levers work, well then draw the lever and show me how it works. Explain it, show it. And if you want to do experiments, that's fine, but don't do really stupid and crude ones and then claim they're brilliant proofs. That's really lame. Alright, so not conceding that you're not very good at engineering a quick release or something, that's really bad science. Is when when you're pretending you know what you're doing when you don't know what you're doing. And there's all kinds of mistakes you could be making. That's the funny part. It's just that, they have absolutely no right perception, of the fact that, oh, that's right, I never went to do experiment school. I'm not a professional. I haven't done millions and millions of experiments and figured out all of the mistakes you can make. I mean, I'm sure the famous experimentalists of time, they all learned something, right? I mean, Faraday worked for Hooke, I think it was, right? The other guy. Well, anyway, and he saw what happens. I mean, the guy almost blew out one of his eyes in an experiment. So I mean, he kind of learned that experimenting can be dangerous, and that you have to do certain processes. I'm sure in Faraday's experience, he learned lots of lessons through experience. And so again, I had the experience, Brozo. There should be a collective, resounding applause for the idea that yes, we should have very well-engineered release mechanisms. That it's important, that you can really change the results by fucking around with release mechanisms. So yes, that's something you really have to concentrate on. Everybody should be all saying that from our learned experience, and yet they haven't learned a damn thing. Amazing. So Tim says, the collisions you have drawn on the board, are those different than the conventional physics says? Conventional physics doesn't deal with it. They don't deal with the relativity argument. So they'll do this experiment, and then they'll do that experiment. But they won't show them both and then explain how, relativistically, obviously these two experiments have different outcomes. So I can't pretend that if the two trains have a different mass, I can't pretend that it doesn't matter which one's moving and they can never tell which one's moving and all of that kind of crap. Because of course you can. You can assign an absolute in the sense that you can say definitely the momentum was going this way or definitely the momentum was going that way, because the outcomes for the two will be different. That's all I'm saying, is that they're clearly going to have different outcomes. If I crash them into each other, I'm just saying that they'll obviously be not the same collision, as long as I make the trains different masses. I'm just saying, it's like the mv squared argument. I mean, maybe an argument that simple blows up the relativists who claim relatively means there's no absolutes in the universe. So I think it's just an argument against the non-absolute universe people, the non-three-dimensional absolute universe people, the non-Newtonians, you could argue. I mean, Newton was a little bit explicit about saying, it seems pretty plausible that there's three dimensions and, there's real motion in those three dimensions. Now, he has his bucket argument, which is also a pretty good argument, frankly, about why the water, as you spin a bucket. But again, they don't use the right logic. They don't explain why the water starts to move is just because of friction. But once you get the water moving or swirling, it has no choice but to go up, whether it's gravity or not. Yeah. How will the outcomes be different with what you predict and what conventional physics predicts? Well, I'm just saying, you can't understand. I just drew it. The two outcomes are different. If the heavy thing has the momentum, both objects move in the same direction. If the light thing has the momentum, they move in opposite directions. I mean, can I be more explicit than that? I mean, that's an obvious. I'm saying you can also tell by the the fact that you can just measure the momentum of the experiment, you can see that the momentum of the two experiments won't match. So you can do it both ways and see that the momentums don't match either. Or you can just do it one way and just decide based on the fact that if they both go off the same way, you know the heavy thing had the real motion, and if they go off in different directions, you know the light thing had the real motion. Physics is saying you can't tell the difference in some real way. Like there's no physical reality that would that'll allow you to see it because there is no difference. This is just like their Heisenberg crap, right? They say particles don't have a location and don't have it. Well, yeah, they don't as long as we can't see them. You can make up any story you want, right? So they can say they have feathers, and they say they have glitter, and they have lots of stuff. They can say it, but yeah, I can't disprove it because I don't have a way of seeing an electron. But I'm just saying this is the same kind of story where they tell you an absolute that there's no way of telling the difference because there is no difference. They're arguing there is no real universe in 3 dimensions. They're arguing for some sort of wooey, everything's happening now, and time is a location, and I don't know, all this crap that has nothing to do with physics, frankly. I mean, it's not physical. They don't have a physical theory. Alright, well, 2-minute warning or something like that anyway. 1.5-minute warning. 48-second warning. Something. So, nobody's got nothing to say, then I'll say nothing. But, to summarize the argument to disbar, you are justifying, right? Me saying, okay, I have a acceleration or a velocity of 30 miles an hour. And you're saying it makes sense for you to say that's a rate, 30 miles an hour. It's how much I do something in a unit of time. And you're saying it makes sense to you if I want to know how much total I did to square the 30 miles an hour, okay, and it doesn't make sense that what you're supposed to be doing is multiplying the number of hours it's the number of hours, not the 30 part. The number of 1 unit of hour is what you're supposed to be multiplying. So you're supposed to multiply 5, say it's 5 hours, times 60, not 60 times 60. And it's even dumber to multiply 60 times 60 and then multiply that by 5. Okay. So if you push a 1 mass into a 2 mass going east to west, I will get a different result from pushing a 1 mass into a 2 mass going west to east. Yes, you have the masses in the same place. Yes, so I drew it. I mean, the drawing isn't simple enough for you. 2 mass, 1 mass. The energy is going this way. 2 mass, 1 mass. The energy is going the opposite way. Well, obviously this way and then this way. Yes, I gave you those 2 examples. Yes, the outcomes will be different. If the lighter mass is hitting the heavier mass, okay, the outcome is going to be part of the energy is going to get reflected. The light mass can't get high velocity into a heavy mass, so part of the energy is going to get reflected. And the heavy mass will take on a very tiny velocity. And in the case of the heavy mass, the 1 mass will fly off, The heavy mass will keep going, and so they'll both be going in the same direction. Guaranteed. No, I'm always pushing the one mass. Yeah, it doesn't matter which direction you're going. If you're pushing the one mass, then you'd have the same experiment. Going east or going left, right or left with the same experiment ain't going to mean anything. You're already in the same frame. You're all moving the same way. There's no east and west difference. You can't create any east and west difference. All you can do is create a relative difference between the two objects. So I don't understand. I mean, I thought this was really simple. I mean, how can people get fucked up on this? The heavy mass is moving. It hits the light mass that's not moving. The outcome is this. Okay, both objects go that way. The heavy mass is stationary. The one mass moves at the same exact velocity towards the heavy mass and hits it. The outcome is this. The light mass bounces off in the reverse direction and the heavy mass barely moves in the opposite direction. The two outcomes are different. Oh, fuck. But the Earth is rotating 1,000 miles an hour, so it should be an absolute difference. You can't make an absolute difference because they're both doing that right now. So they're already in that precondition. So you really can't undo what they both already have, which is whatever that is. Whatever that motion is, they both already have it. All right, so you can just do the little differences. You can't do any big difference. Changing whether one thing's going 995 miles an hour or the other thing is going, I don't think it can go faster. Yeah, I guess it could. 1,005. It's still the same difference. It's not going to help you any. What doesn't know, it's really just dangerous to even get into that, because what you're really saying is that condition is what they both already have. They both have to have the 1,000 miles an hour, or they couldn't stay in this. They couldn't be in the same position. So when you give something a velocity, it has to be a real one. Let me just think if there's some way you could detect that. Yeah, that drawings are so simple enough to understand. Okay. Well, just as a statement, I'm just saying it's just a fact that that is the outcome. So I'm just saying it has to mean something. The fact that the two experiments do create a different outcome. You can't just do this assuming that, oh, it's the same difference which way I go. It doesn't matter. Well, it does in fact matter. I guess the argument would be is all you can do is add energy. You can't subtract from the energy they both share. So there's no way to subtract energy. You can only add energy. So with the pendulum swinging, this is the tricky part, right? If you swing something on the pendulum, and the Earth is moving 1,000 miles this way, and that's doing this and this. But see, I'm just saying the collective motion is always changing, so I guess that's the catch. You're not moving 1,000 miles an hour this way every millisecond. Every millisecond, you're doing all kinds of different motions. And it's only over a length of time that it turns out that you're moving 1,000 miles this way. Because you're really moving up and down in gravity, right? You're really moving in the whole galaxy. You're really moving in all these other directions. So your real motion is never 1,000 miles an hour that way. Your real motion is that, because that's an average over a period of time. Your average velocity is all over the place. And that's why the experiment where you're making the velocity addition only in one direction, Earth's gravity, creating a real decisive force in one direction. So all the force you're adding here is just in one single direction. So I guess that might be the way to understand it, is that your absolute motion in the universe is very herky-jerky. And it has tendencies in a direction, but the tendencies are only revealed over a period of, longer periods of time. And at any one moment, you're not moving 1,000 miles that way. The one mass would have a 105 in the direction and 990 in the other direction. Well, as I just explained, that's really not true. So I'll assume you didn't hear what I was saying while you were typing that, but whatever. I would argue that Earth's gravity is decisively a real force pushing you with real energy in a real direction. And so that's your real constant velocity imposed by a decisive force, where your relative motion is this. The motion that you're both doing together is all over the place. And so for the period of time of the experiment, the motion changed created by gravity is going to be decisive. And the various motions is not. I mean, this goes back to even why laser beams spread, right? I mean, why does the light from a laser beam spread over distance? And I'd argue it has something to do with this fact that you can't really shoot photons from exactly the same location because the atoms are moving too much. The atoms that are creating the photons. And that motion, and then the target is also moving. And so that's why it ends up spreading, is because the target's moving and the gun is moving in trillisecond components of motion. But this is a subject that really, there's some subjects you have to spend a lot of time drawing it on a piece of paper and going over it and over it and over it. And this is one of those. Like I said, I just thought of it the other day, a couple of weeks ago. It occurred to me that, the two experiments aren't going to be the same. So it's sort of a wide open door to walk through to say, well, that's a catch that you have to explain. You can't really talk about there being no absolutes if there's a real difference between those two outcomes. I mean, there's also, you can do the pendulum thing where you just hold the pendulum swinging back and forth, and then you go in the direction that the pendulum's moving, and the pendulum doesn't swing back. Okay, it just keeps going forward because you're allowing it to keep going forward. And that's sort of an interesting experiment. Just figuring out that dynamics in the context of a planet spinning. And so, because you would think it would give you some indication that if you were going in the direction of the spin, that it would multiply the effect. But the problem is that that rotating velocity isn't what it, the number, 1,000 miles per hour, is, it's a big number. It's a big speed. And you'd think you'd be able to see the difference, but we can't see that difference while we're going 1,000 miles an hour. All we're seeing is the 5-mile-an-hour difference. How else to say that? But maybe there is some way to detect that motion, I mean, the big giant pendulum does detect it, right? Just hang a big pendulum with a long string, and it will, migrate, based on the motion of the Earth. I mean, you can use it to tell where you are geographically, I guess. But yeah, probably too much of a subject for this video. Well, this format, let's say. I suppose, put simply, if I can show an absolute difference in an outcome, then it's pretty hard to say there's no absolute reality. I mean, because there's just no way to explain why it could matter in a relativistic. If motion was just relativistic, then momentum wouldn't be real somehow. And clearly momentum is real. It has real consequences. Let's see. If you just use even masses, so again, you just break the experiment if they have the same mass, because the transfer is complete with the same masses, and collide them in different directions, you should be able to tell, assuming there is an absolute still frame. How could you tell if you use the same masses? That's a Newton's cradle. I mean, it's a perfect transfer of the energy, so how would you be able to tell anything? And it's obviously the same momentum, regardless of what object is moving. It would be the same momentum. So that experiment just doesn't provide any insight at all. I mean, that's what physics does. They do all the experiments in a very controlled way, and so they just don't do the experiments that'll show that those rules don't apply. And that's why, I mean, the obvious defect in the kinetic energy theory is it's 1/2 mv squared. So they're using mv in the formula, and then saying, I don't have to conserve mv. Well, how can you not conserve it when, it's in your formula? And then on top of that, the simple argument is that all I have to do is create a system that changes from big things, the momentum's in a big thing, and I put it in a small thing, and I'm going to guarantee creating free energy because of the v squared. And if I go the opposite way, if I have the 5-ton train and I turn it into a 10-ton train, I lose all kinds of energy without any explanation. And again, they'll say that you made sparks and you did this and you did that. I can't conserve the momentum, that is, have exactly the same momentum, and break metal and bend metal and do all of this crap, because it takes momentum to do that, right? So it takes energy to do all that stuff. I can't pretend I did it all without using any momentum. I mean, how could I theoretically push on something, have a bunch of stuff go in different directions, and still collect all the energy of the push, all the momentum? That's just the saying, I can just give back exactly what I started with, and I can bend metal and create heat and sparks and do all that other stuff. I can send a bunch of energy into the universe, and I could just restart over the same experiment, create a bunch of heat and sparks, and restart, do the same experiment, because I never lose any momentum. How could that possibly make sense to somebody? That you could just, put the energy, the momentum in, okay, make a bunch of sparks, all kinds of shit, get exactly the same momentum back out, make sparks, make heat, make ducks fly, do all kinds of stuff, start all over again, bake more sparks, lightning, all kinds of crap, burn down houses. How can that make sense? I mean, that's what the theory is saying. It's right overtly stating that somehow makes sense. How could that make sense to any of you? How could you say to me, okay, I take a 5-ton train, and I connect it to another 5-ton train, and they go off at exactly, because I didn't lose any energy, the same total momentum. So it's exactly half the velocity. How could I make the argument that I lost half the energy? And that I lost half the energy by making a bunch of bent metal and sparks and sounds. And yet I have exactly the same momentum. So I could just restart the experiment with the same momentum. I mean, it goes all the way back to 2 years ago with the physics girl experiment. I mean, I'm just saying, why do you people think that can possibly make sense? That you can have a momentum in, you can do a whole bunch of work, and get the same momentum out. I mean, to me, it obviously obliges you to do some serious thinking about the credibility of your theory. I mean, it should do that. And just like this simple argument that the outcomes are different, it should make you think about your theory's credibility, because it's a piece of decisive, ooh, that can't be right. You should be saying, that can't be right. If I'm saying that happens, I'm saying something wrong. All right. If you use, let's see. Okay, the times. All right, we did that. Yeah, we did the same mass thing. If there is such a thing as a still frame, okay, the solar system is moving through it in one direction. Yeah. But so is the galaxy. I mean, maybe the galaxy's going this way, right? Swirling this way. The pancake is swirling this way, but the galaxy itself is moving that way. And then inside the galaxy, the sun's going around, but it's also orbiting this way, right? So they're all counter motions to each other. So you could argue, theoretically, the further out you get in the universe, the more complex your motion, the more there is no motion, because the motions are all undoing each other, theoretically. But yeah, it's a real subject. I'm just saying it's kind of a hard subject to just do in your head, okay? All these, keeping track of all the frames. Yeah. So colliding an even mass in the direction of the solar system versus against the direction would mean the moving mass has more momentum one way, and it has the smaller momentum in the other direction. Says you. I'm just saying, I'm arguing that what direction you're absolutely going isn't as simple as just saying I'm going 1,000 miles around the Earth. Because obviously the Earth is moving through the solar system. The sun is moving in a direction, the Earth is moving in the same direction as the sun. So it's a little bit more complicated than saying you're going 1,000 miles an hour this way. Those are just averages over time. They're not what you're doing at any instant. When I have time, I'll give it some more thought. I mean, I thought I had the argument against why you can't use your collective motion in the universe because of the very inconsistency I'm arguing for. You know, the fact that you have to surmise that in the universe there's so much energy going this way and almost so much energy going that way, and that the more complex your motion, the more it's going to average out. You know, that one thing is going to be pushing you this way and another thing is going to be pushing you with a vector, with a component against that direction. And then some other thing is pushing with another component against that direction. And so that you would be more and more likely to be averaged out than to be, for all the aspects of the universe to be pushing you in the same direction would be a highly unlikely. Because if you're being pushed this way by something in the universe, it means there's less in the universe going that way. I mean, there's more going this way than going that way left in the universe. So if I use some of this to move you, the rest of the universe has more of that in it. So it's more likely that you're going to get hit with some more of that in some other interaction. I'm sure that's part of the solution, understanding that, but regardless. So colliding an even mass in the direction of the solar system versus against the direction. So I don't know, this even mass stuff, you keep going back to it, and I've made the point that it's a bad way to do the experiment because even masses create exactly the same outcome. It doesn't matter which one's moving. Would mean the moving mass has more momentum one way than it has the smaller momentum in the other direction. Yeah, but it's just the Newton's cradle. I don't know how to say. You're not going to be able to detect any differences because all the energy is transferred from one object to the other object. So you have to do the experiment where all the energy can't be transferred. So you have to use uneven masses because uneven masses can't transfer their momentum, all of it, because it's in the wrong denominations. One thing's bank only takes nickels, the other thing's bank only takes quarters. You know, so you have to convert it, and there's no time for the conversions. But you are like that. I should expect you to, you know, even masses, you know. Yeah. All right, running out again. So, give you a minute or so, see if you have anything else to say, and then I'll just, you know, endeavor to persevere and try again another day. I guess that's all there is. The arguments seem quite decisive to me, so I just don't know how you're not getting it. 9.8 meters per second. Not per foot, per second. Oakley doke. I like to say I'm doing it for you, the people, but I'm really not. I'm doing it for the principle, for the poor truth that can't defend itself. Yes, they have a non-disastrous, horribly traumatic day. Yes, try to do that. Try to have a non-disastrous, not horribly traumatic day. That's all we can really, it's just so dangerous being alive. Any minute, little hemorrhage, blah, blah, blah. Your charming little life will change in some disgusting and grotesque way. It's just so creepy. Oh, God. It's just, I just can't imagine, imposing the wonderful gift on some poor other slob. Oh, God damn. Struggle, struggle, eke, eke. Oh, what a fun game to play. Struggle, struggle, doom and death. Brought to you by Mattel. Yeah. I mean, they really should have the board game. They should have that board game. Struggle, struggle, disease and death. Yeah. I scared myself. So I'll have to delude myself into some other, look at the pretty flowers, some kind of crap. I'll have to distract myself so I don't fall into a dismal depression. Anyway. Oh, good. Julius Sumner Miller read into the guy. He was a butler before he became a physicist. Well, that's interesting, right? I mean, anybody who becomes something later in life, you always have to give them some sort of kudos for, doing that extra effort. I mean, to become a professor, to get your doctorate as an older gentleman, you gotta give people credit for that. But that is bizarre. I mean, Jesus. He's such an eccentric character. I mean, I guess that would make an interesting butler, just because he's so eccentric. But yeah, that is kind of funny. He seems so chaotic and undisciplined, and butlers have to be so regimented and rule bound. So it doesn't really fit in any way. But he is personable, so I guess it could fit that way. I don't know. But even, he has so few, like what you would argue would be called social skills, that you'd think he'd be like a good butler is somebody who gives you advice, the red shoes really don't go with the purple pants, something like that. Apparently he did kids show for money, and he didn't even like kids. Well, of course, but yeah. So what? You take your opportunities. I think he loved physics, so I think he loved the idea of educating people, and he probably wished he could do a show for intelligent people, but he did do a show for the military. I remember he took a special trip to a boat or something and did some physics show for the Marines or something. And so it was a little better. But teaching physics to people who don't know any physics, that's really an arduous task to go through all this crap And the physics itself has gotten so convoluted and mushy that there's absolutely no way you can explain. I mean, you listen to some modern physics talk this shit about multiverses and all this crap. I don't know, it's just such a pile of shit. And, when I was a kid, the only real flaws were the wave-particle thing existed and some kind of dualities, but it didn't seem nearly as complicated because they didn't spend much time talking about multiverses and entanglement. I mean, they didn't talk frankly, there was no time. I can't think of anything in my physics education where anybody brought up the concept of entanglement. But anyway. Well, thank you for the research, I suppose. I know sometimes it's not good to know things because you find out things where, and he turned out he was a child molester. And it turns out, you don't really want to know. I mean, it's like Professor Lewin did get caught doing some hanky-panky with his students. It's like, well, I probably would prefer... you always want to know the truth, but I just mean sometimes the truth is inconvenient and troublesome. And so that is a little bit tainting, because you'd like to just give the guy credit for blah, blah, blah. But the other part that I realized, is when I saw the 1950s videos and that he was basically just repeating the same analogies, the monkey falling from a tree, all the same experimental gimmicks that were being used in the 50s, and he's just rehashing them. I thought that was kind of lame because I thought he had kind of thought up these experiments. I didn't think he was just duplicating the theater somebody else had thought up. So so some truth is good because you want to know the guy's kind of lame, but some of the stuff, it's less, yuck. I'd rather not know that fact. So, anyway, hard to measure eccentricity, actually, I suppose by a lot of standards I'm quite eccentric, but I don't feel like I'm all that eccentric, I don't walk around saying, I'm doing the eccentric thing, but I suppose I have some of that. Quirks of personality and such. And appearance, I guess. See, my appearance seems normal to me because, I grew up in the 60s and, I look like the 60s, so I don't feel abnormal. But yes, compared to what you see walking around, it's a lot worse than star-bellied sneeches versus no-bellied sneeches or whatever. I mean, man, people are really sneeching all over the place. Just insanely bizarre. You can't even tell we're sneeches anymore. Ugh. I mean, the definition of human is in jeopardy. But anyway, it's the way it is. World has gotten quite weird in ways I certainly didn't anticipate. I thought it would get so much smarter. It's just gotten so much dumber. But anyway, till the next, that's only a temporary condition. So, it's good. It'll recover. Maybe. Maybe not. Anyway, alright, so apparently it's time to go. Alright, so till the next time and such and so forth and whatnot. Blah, 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 blah.